Okay, so this is where you start needing to learn some laws of logs, okay, or the rules of logarithms. But they actually all tie into your laws from National 5 indices. At the end of the day, if we've got y equals a to the power of x, okay, obviously that involves an index. If we're going to rearrange that, then the laws of indices that we learned in National 5 apply in some way, but it's basically just the rearrangement of them. Okay, as you'll see from this, but it's worth knowing all of these anyway. So if you've forgotten all these, then you might want some practice on these. You might want to kind of take all these down. Okay, but a to the power of m times a to the power of n, as long as those bases are the same, it doesn't need to be a, it just needs to be the same, then we would add those indices. Similarly, if the bases are the same when we're dividing, then we take away the indices. Okay. If we are multiplying indices, okay, so a to the power of m to the power of n, then we multiply the indices. If we have a to the power of minus m, okay, this is an important one to remember because it's the one everyone forgets. It's 1 over a to the power of m. If we have a number in front of it, though, or something multiplying it, we've got to remember that it's just the a that's to the power of the minus m. So the a goes to the bottom with the m, but b is multiplied, so it stays on the top. And then same idea if we have roots. So the nth root of a to the power of m is just a to the power of m over n. And then if we have a to the power of 0, anything to the power of 0 is just 1, okay? And then if we have a to the power of 1, this is a useful one for logs. Okay, we kind of know this one for indices anyway, but that is just a. Okay. These can be applied to logs to give us a similar set of rules. The idea is, if you think about these bottom ones at least, okay, if we have something equals something to the power of something else, that's what we're doing when we're applying logs. We're rearranging it into a logarithmic form, okay? We can do the same with basically these rules to give us a set of laws or rules for logarithms, okay? So if we have a to the power of 0 equals 1, if we rearrange that into logarithmic form, that would tell us that the log of base a of 1 equals 0. And that's your first rule of logarithms. The log of base a of 1 will equal 0. So it's just one of these things that you need to look out for. In the same way that if you ever had anything to the power of 0, you'd know instantly it was 1. If you have the log of anything, it doesn't matter what that thing is, log of a of 1, that will always equal 0. Okay, similarly with that second last rule, or is the last one I think in those rules of indices, if we have a to the power of 1 equal to a, then the log of base a of a will equal 1. In other words, if these two values are the same, so the log of base 7 of 7, that will equal 1. The log of base w of w will equal 1. Okay, and that will give you a second rule of logarithms, right? In the same idea when we're doing indices, this is not specifically the second rule of logarithm. This is just a bunch of rules of logarithms, and I've just decided to call this one rule 1 and rule 2. Okay. Right, this one is basically going back to the first rule I gave you in terms of indices, okay? But again, we've got this situation where the bases are the same. I've got a bunch of other numbers, okay? X, M, Y, and N. They're not necessarily related until we start trying to combine them together. But basically what you're looking out for in this case is where you have the bases that are the same, in the same way that you'd look out for when you have indices, okay? So X equals a to the power of M and Y equals a to the power of N. If we were to multiply those two things together, x and y, then we'd add a to the power of m times by a to the power of n, which would just be a to the power of m plus n. Okay, I realize this is awkward explaining it with letters, but take your time going through it. This is nothing new to you at this stage. The idea is we're going to try and apply this to logarithms. Okay, so the log of base a of xy equals m plus n. So this is just going back to when we, in terms of everything that we've done in terms of laws of logs. Okay, if we have something equals something to the power of something, okay, then the log of the base, in other words, the thing that we're doing the power of, okay, so log of base a of xy will equal m plus n. In other words, okay, the log of base a of xy is equal to the log of base a of x plus the log of base a of y. Okay, because we're basically linking this back to the start. Okay, we had m equal log of base a of x, n equal log of base a of y, and I know I've lost you at this stage. I know you're getting confused because I'm saying log all the time and you still don't really know what a log is. Okay, but just think log is a mathematical process. It's all we've got here. And this is the kind of situation you're looking for. And again, it's one of these ones that you need to spot in the same way that you spotted in indices when you had a to the power of m times by a to the power of n. You instantly knew you had to add those indices. In logs, when you have two things that have the same base, so log of base a here, log of base a here, if we are adding them, then what we can do is we can take the things we're finding the log of base a of and times them together. And then we'll have the log base a of that number, okay? And this gives you another law of logs, Okay, and as I say, it's more commonly written in the other way, and this is what you'd be looking out for. You can do it this way too. If you have two things multiplied together, you can split it up, and sometimes that can be easier to work with. Okay, but as I say, in many ways, this is just what we're doing in terms of indices. And because of indices, vice versa also works. So if we have two things divided, okay, then we obviously take away the indices, and therefore log of base a of x divided by y will equal the log of base a of x minus the log of base a of y. Okay, this will make much more sense when we start showing some numbers in. Okay, so just bear with me just now. Okay, and that gives us another law of logs. So when we have the two bases the same, okay, log of base a, if we're taking them away from each other, then we can just divide the x and the y into one log. Okay, so let's put some examples in this, so this makes a bit more sense to why it says and vice versa. So this is what you're looking out for. We have log of base 3 of 8 plus log of base 3 of 2. And suddenly you're thinking, oh my god, what the hell's going on there? But the idea is, hopefully you're spotting the fact that they have the same base. And if they have the same base, then we can take these two numbers and we can multiply them together to give us just one log. Okay, one log is better than two logs. So this will give us log of base 3 of 16. Okay, and that's literally it. If we wanted to, if we felt the need, we could put that into a calculator, but for this one, we don't necessarily need to do that. Okay. So for the second one, same kind of idea. Okay, we've got the same base, okay, and we're taking away this time. And that means when we're taking away in terms of logs, then we can divide the things we're finding the log of base 10 of. So it's log of base 10 of 50 divided by 5, which is log of base 10 of 10. And then you're thinking, going back to those rules from earlier, if we have this situation, log of base 10 of 10, if these two numbers match up, then that overall is just 1. In the same way that if we had 10 to the power of 1, it's just 10. Because we rearranged this into logs, we know that log of base 10 of 10 is just 1. Log of base sausage of sausage is just 1. Okay, and that's what you need to spot. This is what you need to look out for. So these rules. Yeah, so that's them all written on one page for you. Am I going to do some more? Nah, I'll leave it there.